Hi, Assalamualaikum. Welcome back to my channel. So today we have the first slot for tutorial to discuss trial SPM questions. So this one will be set 1, chapter 2. Okay, for section A, 60 marks. Okay, answer all questions in this section. Okay, perlu jawab semua soalan. Okay, look at the first question. Given an equation relating the photon energy E, speed of light c, and wavelength of light lambda. So we have the formula E equals to hc divided by lambda. Okay, if you refer to the list of formula, or if you still remember the formula for photons energy, E equals to hf. F equals to c over lambda. Okay, what is the meaning of wavelength? Definition for wavelength. Okay, so we have more than one, just take one definition. Distance between two consecutive crests or trough. Okay, or you have another definition like distance between 2 points which are in phase also can. Okay, just take one definition. Second, complete the following sentence by picking the correct answer. Symbol H. Okay, symbol for H represent Planck constant. The value you can check in the list. This value is determined from the experiment, Planck constant. What is SI unit for H? If you refer to the formula given, E equals to HF. Okay, so H is equals to E divided by F. E is joule, frequency is hertz or second negative 1. Negative 1. Thus we get joule second. Okay, so that one will become the SI unit, or you want to write in this form. Joule is equals to kg meter squared second negative 2 multiply second. So kg meter squared second to the power negative 1. Okay. Okay, or joule second. Okay, part D, what will happen to the photon energy if wavelength of light lambda increases? So from the formula again, E equals to Hc over lambda. If lambda increases, the relationship is inversely proportional. So the photon energy decrease. Okay, based on this formula, E inversely proportional to lambda. Alright, number 2. Diagram shows gravitational force acting on the boy and the girl of mass 70 and 53 respectively, separated distance r 1 meter. What is the meaning of gravitational force? Force that acts between two objects in the universe. Okay, any two objects that separated a certain distance will experience this gravitational force. Okay. Formula F equals to gm1 and 2 divided by r squared. State the unit of F in terms of base unit. So in terms of base unit, from the formula, this formula also can be used if you, or you can just derive from here, or from this one, the same formula. Force is kg meter second negative 2. Okay, this is in terms of base unit. When we talk about base unit, there are how many? 7, right? Kilogram, meter, second, okay, Kelvin, candela, mole, okay, the one you call it base unit. Calculate gravitational force F. Okay, you just substitute all the values. Six, seven. Okay, you have the mass 70, second object 83, separation distance 1 square, 1 meter. So we get the answer is 2.45 10 power negative 7 Newton. Okay, so this is the force that act between the two person just now. Why the boy and the girl did not experience the effect of gravitational force toward each other? Because as you can see, the value were 2.45 times 10 to the power of negative 7. Means this value is very small. Okay, so you can say that the gravitational force acted between them is too small and unnoticeable. Okay, so So, sangat kecil value sampai tak boleh dirasai ya oleh kedua-dua orang tu. Okay, number 3, coherent sound wave are produced by two loudspeakers S1 and S2 separated by distance 0.5 meter. S1 and S2. What is the meaning of coherent waves? Okay, before that, let's look at diagram 3. So the diagram shows there are two sources S1 and S2 connected to the same main source, signal generator. If they are coming from the same source, means the wave that produced by S1 and S2 must have same frequency. So when the wave produced by these two sources have same frequency, so we call it coherent sources. The sources that produce waves with same frequency. Okay. The rest also can be added like amplitude and same phase. So we call it coherent sources. State whether sound is transverse or longitudinal. Explain your answer. Sound wave is the only wave which is longitudinal. The rest all are transverse. Okay. Okay, explain. Molecules of medium because you can see for sound wave it need medium to travel. Vibrates parallel to the direction of sound wave. So example, like if sound wave travel in air, so molecules of air will vibrate parallel to direction of sound wave. As you can see, it will produce compression and rarefaction region. Compression, rarefaction. Compression, rarefaction, and so on. So it means the molecule will vibrate parallel to the direction of wave. Okay, so this one we call it longitudinal wave. Okay, part B, a student walks slowly in front of in front 2 meter away from loudspeakers. In diagram 3, the position where very loud sound are heard are labeled L, and position where very soft sound are heard labeled S. Okay, 2.5 meter away from the loudspeakers. In diagram 3, position where very loud sound are heard are level L, and position where soft sound level S. Okay, you can check again the diagram. Yeah, loud and soft sound alternately from here. So if you look at the level, this is separation between two coherent sources. So A, distance between sources and the line where X is measured. This is D, distance between two consecutive, okay, loud sound. This is X. Or between soft sounds, same thing, same length. Okay, the one is X. State what happens at points level L. You can see at point level L, loud sound is heard. Okay, at point L, loud sound is heard. Okay, due to constructive interference. Okay, distance between three consecutive loud sound. Let's say we have loud. Okay, so this distance is 8 meter. Between two is X. Okay, so we can calculate X equals to 8 divided by 2, 4 meter. Okay, so we want to calculate for lambda. Lambda equals to EX divided by T. Okay, before you substitute, check the unit. All must be the same. So all in meter, so I just substitute. A equals to 0.5 meter, X 4 meter, D 2.5 meter. So I will get the answer 0.8 meter. So make sure the unit is correct. If you write cm means, even though here you write 0.8, your answer is wrong. Okay, because in terms of its value will become different if we use different unit. So answer is 0.8 meter. Okay, number 4. Diagram 4 shows an acrobat stand still on a tightrope. Acrobat experiences equilibrium of forces. So once you read through the question or you look at the diagram, okay, try to identify concept involved. Any concept, any law or principle. Okay. Okay, look at the angle given. So this is weight W equals to mg. This is the force or tension of the rope T2 and tension of the rope T1. Angle given. The mass of acrobat is 50 kilogram, T2 450, gravitational field strength G 9.1. So this one will cause the value of acceleration due to gravity to become 9.81 meter second negative 2. Don't use 10. G ya. Okay. Jangan. So what is the meaning of equilibrium of forces? Keseimbangan daya. So we can write down the resultant force of the forces of the forces is 0, or the vector sum of the forces is 0. So same meaning. So write one definition. What should the acrobat do to maintain her balancing while walking through the road? Explain your answer. So you can suggest, give one method for the acrobat to maintain her balancing while walking through the road. Maybe you have watched somewhere, they use something like one stick, holding a long stick. Horizontally, to balance her weight to increase stability, or any other idea. In the space below, sketch. Sometimes the word draw. If draw, that you must use scale to draw. Use ruler and protractor. Now just sketch. In your sketch, indicate direction of forces, label all the forces and show angles involved. 3 marks. We look again here. Maybe we can try to sketch here first. So this is the point of equilibrium. Normally when we draw the one which is vertical or horizontal first. Let's say this is the first force that we draw, W. And then end of the first force, continue to draw the second one. I will draw T2. This is 90 degrees, means angle here is 40 and here is 50. So at angle 40 from vertical line, I will draw the second force T2. This is 40 degrees. And then end of the second force, I will draw T1. So this is T1. And the angle here is 27. So I have this one, this diagram. Roughly sketch. Now I want to draw or sketch, in the space given. I will draw it here. Okay, then I will continue to draw the second forces now. Third one. Okay, now we need to level. So this is W, this is T2, and this one is T1. The angle here, 40 degrees. $27 here. And then here is 63. Okay. Okay, so you must label angle and this 50 here. Label the force and also the angle with direction. That's why here is 3 marks. Okay. Determine tension of the rope T1. Okay, there are more than one method for you all to solve. You can use mathematical formula like cosinus formula, or you can use resolution of a force to determine. Okay, let's say I use resolution, okay, to solve or to find the value of T1. So when you do resolution, make sure you resolve all the force here, W, 50 and T1. For the one already vertical or horizontal, no need to resolve. So I will resolve it to two components. Components horizontal, the X component, and component vertical, the Y component. Okay. So if you resolve T2, I will use this angle 50. For T1, I will use this angle 27. Okay, resolve for T1, you will get T1 cos 27 here, and here you will get T2 cos 50. T1 here. Okay, for the vertical part, this one will become T1 sine 27, and this one T2 sine 50. Okay, just now mentioned already here, equilibrium. When equilibrium means forces are balanced. The upward force equals to downward force. The left side one equals to the right side one. Means all are balanced. Horizontal balance, vertical balance. Now we try to determine T1. Okay, let's say the horizontal component. Horizontal component, you will get T1 cos 27 equals to T2 cos 50. So this one will become the first equation. The vertical one, you have T1 sine 27 plus T2 sine 50 equals to W. Okay, so we have two equations here. From 1, T2 equals to T1 cos 27 divided by cos 50. So I will substitute T2 in order to get the value of T1. W is mg, 59.81. Okay, so now you can try to solve for T1. You get 1.52. Or given P2 already, so if I use this method by substitution, we get P1. So if given P2 is 450, so I think from first equation already we can get the answer. Okay, so from 1, so I just show to you here if T2 not given, but in this question T2 already given. If T2 not given, you can use this method, so you get the answer like this. If already given, then we just use equation 1 to find. Okay, this one. Second. 450 cos. Okay, there is a slight difference in the answer given. Okay, number 5. Number 5, diagram 5 shows parts of electromagnetic spectrum with their respective wavelength and frequencies. So you can see electromagnetic wave, gamma rays, X-rays, ultraviolet, visible light, infrared. Okay, Y, what is Y, and radio wave. Yeah? What is the meaning of electromagnetic wave? Hi, I know Fatiha. Please stop sekejap sebab ada azan. Okay, continue. What is the meaning of electromagnetic wave? The wave that produced by vibration of electric field and magnetic field. So it does not need medium to travel. So this is the special about electromagnetic wave. Okay, based on diagram 5, compare wavelength of gamma and radio wave. So you must know from this one. I think from the diagram also you can determine distance between two consecutive threads. This one obviously is wavelength or lambda. So from gamma to radio wave, distance between two consecutive threads increases. Okay, so frequency decrease, wavelength increase. So if you compare between gamma and radio, we can say that wavelength of gamma rays is shorter, lebih pendek than that of radio wave. Okay. Okay. And then frequency of gamma and radio wave. Just now you start with gamma, so this one, this part also you start with gamma. Frequency of gamma rays is higher than that of radio wave. So the frequency is higher for gamma, you can see, more number of waves can be seen in the same time taken. Let's say if this time taken is 1 second here, this is 1 second, so you can see how many waves observed for gamma, more number of waves compared to radio. Thus, frequency of gamma rays is higher, okay, than the radio wave. Okay, energy carried by gamma and radio. So you can look at the again, energy increases from radio wave to gamma rays. Okay, so we can write down here based on what given, the energy of gamma rays is higher or larger also can, that of radio wave. Okay, and then using your answers in 6b, state relationship between wavelength and frequency. So you can write the answer when frequency, you can write like you are writing a hypothesis, or you can write something like this. When frequency increases, wavelength decreases. Avoid using the relationship like inversely proportional unless there is graph stated in this question, or they give you diagram which consists of graph, then you can use the relationship like that. Okay, for this one you just write like writing hypothesis, or the higher the frequency, okay, the shorter the wavelength also can. Okay, compare velocity of gamma rays and radio wave, same velocity. Okay, electromagnetic wave spectrum, they are all travel at speed of light. Light, C equals to 3 times 10 power 8. They are traveling at same speed. Okay, name one use of electromagnetic wave at position Y on the spectrum in diagram 5. So from here you can see gamma, X-rays, ultraviolet, visible light, infrared. So this one will be microwave. Okay, you can create a funny sentence just to memorize the arrangement of the waves. Okay, so Y is microwave. See? Okay, just take one only. There are many answers that you can write. Okay, you can use it in telecommunication. Okay, okay, handphone or mobile phone. Okay, microwave for cooking. Microwave oven. Relay. radar banyak okay. Satellite. Okay. Just take one. F. Television station emits radio wave frequency given. This is F. Calculate wavelength lambda emitted by this television station. As we know, it uses microwave in this case, or radio wave, okay, for telecommunication. So all these electromagnetic wave that travel at speed of light, c equals to 3 times 10 to the power of -8. You can refer to the list of formula for value of speed of light. So now we want to calculate using the formula V equals to F lambda. So this is from the chapter 5.4 with V is equals to C. C equals to F lambda. So lambda equals to C over F. So 3 times 10 to the power 8 divided by 2.5 10 to the 8. Thus we get the answer equals to 1.2 meter. Okay. Okay, number 6. Diagram 6.1a and 6.2a show two circuits used to investigate the relationship between potential difference and electric current of constant wire of different thickness. Diagram 6.1b and 6.2b shows graph of potential difference against current. The gradient represents resistance of the constant wire. So you can see from diagram A and B here, different thickness. This is thinner, this is thicker. Look at the graph. Okay. What is the meaning of resistance? Okay, you can use formula actually here to define resistance. Okay. Resistance is the ratio of potential difference current. Right, resistance, okay, voltage divided by current, or potential difference divided by current. Don't write R equals to V over I. Ini tak mahu you kena define semua simbol. Compare thickness of constant wire. Okay. Try to write clear of constant wire in 6.2 is thicker than in 6.1. Compare resistance of constant wire. Just now you start with 6.2, now look at the 6.2 graph. From here, gradient, you can see the line is steeper, means gradient is higher. So this one is larger gradient. So larger resistance. Okay, here smaller resistance. So you can write the resistance in 6.2 is smaller than in 6.1. Okay, ini you start dengan 6.2, ini pun you start dengan 6.2. 6.1 sorry 6.1 okay, 6.1. Relate thickness with resistance. So you can write the thicker the thickness of wire, the smaller or the lower the resistance. Okay, you can see here thicker, smaller. Okay, so you can write again here in part 3. Okay, those online you can ask questions if you have questions. Okay, part C, diagram 6.3 shows 3 resistors X, Y, Z of resistance 20 ohm. Okay, means they are identical, 20 ohm, 20 ohm, 20 ohm. Okay, total voltage 6 volt. Okay, based on diagram, calculate effective resistance of the circuit. Okay, firstly, you can try to mark current in order to identify the series part and parallel part. So this is the total current flow to X, and then when reach this point, you can see it's split to 2. So this one for Y, this is for Z. Because of the resistance are same, thus IY will become equals to IZ and equals to total current divided by 2. So in this case, Ix plus Iz equals to total current, or the current passed through X. Y, sorry, not X, Y, Y, Y plus Z equals to 2. So you can see here, this Y and Z, this part, they are sharing current, so they are parallel part. And then for this parallel part is in series with X. Because you can see this is the total current. Okay. So now we try to calculate for parallel part first, effective resistance. 1 over parallel part is equals to 1 over Ry plus 1 over Rz, because Y and Z parallel. So means 1 over 20 plus 1 over 20, which is equals to 2 over 20 or 1 over 10. So the parallel part equals to 10 ohm. For the whole circuit, okay, for the whole circuit, R effective, okay, is Rx plus parallel part. 20 plus 10, so we get 30 ohm. So this is for the whole circuit. For the whole circuit, 30 ohm. We want to find current I, part 2. Current I here is total current. Using the formula V equals to IR, you will get I equals to V over R. If this one is total current, so voltage must be total voltage and R must be total resistance, or we call it effective resistance for the whole circuit. So 6 divided by 30. So we get 0.2 ampere. So this is the total current. Power dissipated at resistor X. Formula, we can use formula VI. If you have voltage across X, then you can use VI. Means if this one X, So you need to calculate what is voltage across. Okay, so I don't have V. You can go and calculate first. Huh? And you can use I squared R. Okay, current passing through X is 0.2 squared X 20. Okay, so the power dissipated by X is caused by resistance of X. Okay, so P equals to I squared. What will happen to the current if resistor Z is removed? If Z is removed, this part, so we just have two series resistor. So the effective resistance will become 20 plus 20. Okay, if you remove Z. So when effective resistance increases, what happens? The effective resistance, and the new one will become 20 plus 20, which is 40 ohm. Okay, so what happened to current? Current equals to V over R. That's 6 divided by 40. Okay, this one is by calculation, but this one just mentioned what happened only. I just want to show to you what happened. So you will get equals to 0.15 ampere. So just now is 0.2, means the value of current decrease. Okay, okay, current I decrease. If they want you to explain, you can state that effective resistance increases. Okay, number 7. Diagram 7.1 shows velocity time graph of a car which apply the brake after moving at constant velocity 10. So for VT graph, what you can get from this graph? The gradient equals to acceleration. The area under the graph equals to distance or displacement. You can see from here. State the physical quantity represent area under the graph. So you can write your answer as distance or displacement. Okay. And then state type of motion after 0.5 seconds. So you can see from here, velocity decreases with time. If you calculate the gradient, you will get negative value, negative acceleration. So this one will cause the object to slow down, or you can say, can state the type of motion as negative acceleration, or velocity decreases, or you can state something deceleration, or retardation. Okay, V2, calculate total distance. Distance is scalar quantity, so no need to consider direction. So just calculate the area under the graph. So you can see the shape is a trapeze shape. So we are going to use the formula for trapezium. So total distance equals to area under the graph. So it becomes half. You can look at again the graph here. So this area. Half times 0.5 plus 4 times 10. So we get 22.5 meters. Okay, but see, diagram 7.2 shows a man playing golf. Okay, swung the golf club up to height h. Table 1 shows different type of golf club and height h used in a golf game XYZ. Suggest suitable method to increase distance travel by the ball based on the following aspect. So this topic is about the ball need to move further. So this one is topic of momentum. Okay. So you can get X, Y, Z, the table first. Type of golf club. We can use something which is very strong and hard. Okay. Titanium. Height 2.5. Okay. Stronger and harder material and can reach higher height. So type of golf club, you can just write straight from the table, titanium. Golf club ialah kayu golf tu kita panggil kayu golf, okay? Ataupun golf stick. Okay, reason stronger material, not easily broken, last longer. Okay. Okay. Height h is higher. It will travel faster and further, or has higher momentum. Okay. Okay. So based on your answer, choose the best one. So you will choose Z. Okay, number 8. Diagram 8.1 shows a permanent magnet inside a bicycle dynamo rotating at high speed. Okay. This is a dynamo. There's no power supply. Generator. Topic like electromagnetism. Okay, there is a permanent magnet, coil, bulbs lights up. State the energy changes that takes place at the dynamo. You can see there's no power supply here, no battery. So by rotation, it will generate electricity. So what you can see about the energy change, you can write down as mechanical energy or kinetic energy also can. Energy change you boleh guna arrow. So electrical energy. Okay, state the physics concept. Electromagnetic induction. The current produced when rotates the magnet in the coil will generate current by process of induction. So we call it electromagnetic induction. Okay, part B, diagram 8.2 shows a girl cycling at night. The bicycle lamp a bit dim, although the girl cycling faster. Okay, state modification needs to be done to the dynamo to increase brightness of the bulb. So just now, if the girl is cycling at same speed, okay, so we need to do something to the strength of magnet, number of turns of coil. Okay, she already cycle faster but no change. So what we do, we need to change in terms of strength of magnetic field and number of turns. So these are the factors that affect induced current produced. So the magnet used, you can use a stronger magnet. Okay, reason to produce more flux line being cut by magnetic dynamo. Coil that cuts the magnetic flux of the wire. The number of turns of the coil more number of turns reason increase the rate of cutting of magnetic flux. Flux means field line. You don't know what is the meaning of flux. Refers to the field line, garis-garis medan magnet. Flux. Okay, suitable material of coil or wire. We can use copper wire. Okay, because we are trying to increase the induced current. To increase current, we can use material which has low resistance. Okay, so copper wire has lower resistance. Okay, increase current. Okay, diagram 8.3 shows current induced when U-shaped iron core is moved upwards. Mark at diagram 8.3 direction of current flow in the conductor. Okay, this one you can apply Fleming's left-hand rule. Sorry, this is not Fleming. This one, there is a power supply, betul. Ini ada power supply. So there is a magnetic field of the coil of wire here. So when move up, okay, this wire or conductor, if move up, it will cut the magnetic field lines of this wire. Okay, so direction of the magnetic field for the wire, you can apply right hand grip rule. Right hand grip rule. Okay, current flow like this. Okay, so this one will become this one is sub. Okay, okay, and then you apply Fleming right hand rule. Move up north to south. Current is into the screen. Current is into the screen. So direction of current will be this direction. Okay. Okay. So that's all for the section A for paper 2. For the essay part, I will continue in the next slot, part 2, because I already taken more than 1 hour for the section B. Okay. So for those who miss, you can watch again this video. Okay. So thank you for watching. Bye.